Quartz, low temperature, makes up about 12% of the Earth's crust. It is second most abundant mineral in it after feldspars. Quartz, as noted earlier, has a framework structure. The drawings often give the false impression that all the tetrahedrons depicted in the drawing lie in the same plane. Upon close examination of the three-dimensional model, it turns out that in the frame unique elements of symmetry are revealed. Third-order helical axis of symmetry, and along them, as on the lenses of a spiral staircase, tetrahedrons are located at different levels. These axes seem to be combined with each other tetrahedrons accordingly to the gimlet rule when rotated 120 degrees. During the transitional rotation movement of such a gimlet, the tetrahedrons are combined with each other 3 times during its full rotation. Moreover, it turns out that in different crystals the rotation of the screw axis can occur either to the right or to the left. On this basis, 2 structural varieties of the mineral are distinguished: right-handed and left-handed quartz. The structures of right-handed quartz. The noted structural features of quartz are manifested in its properties and the morphology of its crystals. The high proportion of covalent bonds and the framework structure ensure the high hardness of quartz, 7 on the Mohs scale, and the absence of cleavage. The porosity of the frame structure causes low-density mineral, 2.65 grams to cubic centimeter. The nature of the bonds is also expressed in the good transparency of quartz crystals, low refractive index, about 1.5, and glassy luster. The presence of triple helical axis in the quartz structure is expressed in the fact that the quartz system is trigonal and not hexagonal. Ideally, developed natural crystals are formed by 6 highly developed vertical faces on a hexagonal prism, closed at the top and bottom by triplet of small and large faces. They belong to 2 rhombohedra. The overall height, at first glance, symmetry of this polyhedron is sharply reduced by the smallest bevels on the faces of the prism. These are the faces of the trapezohedron. On crystals of the right quartz, they are located on the prism at the top right. On crystals of the left quartz, at the top left. Sometimes there are thin edges of the trigonal dipyramid. Thus, the real set of symmetric elements is simple. And another characteristic morphological feature of crystals is the rough horizontal across the crystals shading on the faces of the prism. It is formed by combination of the thinnest surfaces of the prism itself and rhombohedrons. In the presence of only element of symmetry in any polyhedron, including quartz crystals, there are popular directions. Such in quartz are, for example, the L-axis, since with any symmetric transformation, rotations around the L-axis or around any of the L-axis, and there are no other symmetry elements in quartz. One end of the L-axis cannot in any way align with the other end, the same axis. Along the L-axis in quartz crystals, its piezoelectric properties are most strongly manifested. When a piezoelectric element is compressed along an axis and physically unequal ends, the degree of compression turns out to be different at opposite ends, and due to the disruption of the electrostatic field, a potential difference will arise between the ends of the plate. On the contrary, when a potential difference is created at the ends of the plate, it expands or contracts. Quartz is the most valuable piezo-optical raw material. Plates are cut from it, the piezoelectric properties of which depend on the rotation of the cut. Only defect-free single crystal or twins, accordingly to Brazilian law, are used. Twinning is the characteristic feature of quartz. 6 types of doubles have been identified. The most common are the Japanese, Brazilian, and Dauphine laws of twinning. Japanese doublets have a V shape. They are twins of the fusion of 2 crystals along the face of a trigonal dipyramid. The fusion place is the plane of symmetry of the twin. The integrals are always flattened. Melkis look like a heart. In Brazilian twins, 1 crystal of the left and 1 crystal of the right quartz grow into each other. The number of trapezohedrons on each face of the hexagonal prism is double. They are inclined equally with respect to its axial line. To edges or sections of the crystal with hydrofluoric acid, you can see that they consist of plates. In the Dauphine twins, 2 crystals also grow into each other. These are either 2 crystals of only left or only right quartz. They are rotated around the L-axis, 60 degrees relative to each other. The number of trapezohedrons doubles. If you look at the face of the prism, you can see the bevels at the top left and right of the center line of the face. They are inclined differently relative to the face of the prism. If you pick, such crystals exhibit intrinsically curving boundaries. It is impossible to cut plates with a piezoelectric effect from such crystal. Quartz is found in crystals, the intergrowth of various types, drues, brushes, granular masses in the form of pebbles and grains of sand in sedimentary rocks, continuous masses and veinlets. A special morphological variety of quartz, chalcedony, is a fine, fibrous, cryptocrystalline aggregates of layered, concentric, banded, homogeneous, always finely porous composition. The color of quartz varies both in color and nature. Ideally, purely quartz is large, defect-free crystals is colorless and has been called rock crystal since ancient times. Quartz with an isomorphic admixture of ferrum and alkali metal cation embedded in the interstitial space has a violet color and is called amethyst, and quartz with the same admixture has a brown-black color and is called a morion. The color centers are ions, which arise due to charge transfer during isomorphism. Color is violet, smoky. All these are the own colors of quartz due to its composition and structure. Of the varieties of false-colored quartz, it is enough to mention two: milky quartz and green quartz, prism. The first is usually filled with tiny 1/100th of a millimeter inclusions of natural solutions from which quartz grew, or in other cases broken up by the finest cracks. In the second, numerous inclusions of green achinolite needles are scattered. These are many other rare color varieties of quartz, usually with their own names: raw topaz, citrine, Compostela ruby, aventurine, etc. There are especially many such names for chalcedony aggregates of different colors: agate, onyx, chrysoprase, carnelian, etc. Quartz is formed under different conditions as the product of crystallization of acidic magmas, as a hydrothermal mineral in skarns, ore and non-ore veins, and other mineral deposits, as a component of metamorphic rocks, as a mineral of sedimentary rocks, etc. Of industrial importance for the development of quartz as a piezoelectric raw material and cutting material for jewelry are granite, pegmatites of the quartz beryl topaz type, and veins of rock crystal or morion among shales. They are called alpine type veins after the places of the first finds. Transparent good ones are sometimes mining them quartz crystals weighing up to 500 kg. Quartz from waste. This production is used for melting heat-resistant glass and as a raw material for growing artificial defect-free piezo quartz crystals. White quartz sands are of industrial importance for the glass industry. Chalcedony as an ornamental stone is mined in mineralitic and other mineralized cavities in volcanic rocks, basalts, etc. Quartz is especially recognized by its prismatic crystals with cross-hatching, shell fracture, hardness 7, glassy or greasy luster. Quartz, high temperature, crystallizes in the form of a well-faceted dipyramidal crystals of hexagonal system which form porphyry penocrysts in acidic effusive rock, and with decreasing temperature are pseudomorphically replaced by trigonal quartz with the formation of paramorphs. Tridymite and cristobalite occurs in acidic effusive rocks. They are observed here in the form of tiny crystals embedded in the bulk of the rock. They usually form thread-like crystallites in partially crystallized volcanic glass.